Hi, I'm Mridula, and this is my Physics 2211 Lab 1 video, Charged Tapes.
So this is the introduction. The purpose of this experiment is to observe interactions between charged pieces of tape and to determine the amount of excess charge on charged pieces of tape. The preview of results are the charge on each tape was found to be 1.26 times 10 to the power negative 8 coulomb, and the number of electrons lost on each tape was 7.875 into 10 to the power 10 electrons. The principles used are Newton's second law of motion, which states that the rate of change of momentum is proportional to the force applied. So the force vector is equal to ma, which is equal to dp by dt. Coulomb's law, it describes the strength of force of attraction or repulsion between two charged particles. So the F vector is equal to 1 by 4 pi e naught, which is the Coulomb's law constant, q1 times q2 divided by the magnitude of r square times r hat, where q1 and q2 are the charged particles, r hat is the direction, and r square is the magnitude. And then finally the gravitational force, which is the attractive force between two objects with mass. So F is equal to the gravitational constant g times m1 into m2, which is the masses of both the objects, divided by r square, and g is negative here. The initial conditions for the experiment are: the system is tape B, surroundings are tape A, and everything else. Mass of the tape is 2 times 10 to the power negative 4 kg. The length of the tape is 0.2 meters. The area of the tape is 0.004 meters square. The area of an atom is 10 to the power 20 meters square, and the number of atoms is 4 times 10 to the power 17 atoms.
So the procedure for the experiment is tape B is stuck to a tape on a table and quickly ripped off to generate charge. And the second part is a tape is placed below a suspended tape on two objects of similar height, and the distance between them is measured. Observations. The interaction between the charged and uncharged tape is repulsion. Charged tape in hand is attraction. Tape in charged pen is attraction. So the conclusion is that the tape is negatively charged, and the interaction between the suspended tape and tape hanging below it is repulsion.
The distance between the tapes was found to be 0.027 meters. The gravitational force, mg, is equal to 1.96 times 10 to the power negative 3 newtons. The electric force is equal to the gravitational force, as the acceleration on the tapes is 0, so that's the same as the magnitude of the gravitational force. And the electric charge was found to be 1.26 times 10 to the power negative 8 coulomb, and the number of electrons lost is the charge of the tape divided by absolute value of the charge of an electron, which is 7.875 times 10 to the power 10 electrons. These are the initial conditions of the computational model to calculate the different types of force and the charge and the number of electrons lost. So this is the calculation part in the computational model. The force of gravity is equal to the mass of the tape times g times the direction, and the charge is equal to the square root of the tape of the mass times g times distance square divided by the Coulomb law constant. And to find the number of electrons lost is equal to the charge divided by the charge of a proton. And I printed the force of gravity, the charge, and the number of electrons lost on a piece of tape. And I also calculated the ratio of atoms for every electron lost on one piece of tape. So that's equal to the number of atoms divided by the number of electrons. These are the results of the computational model. So the force of gravity is negative 1.962 times 10 to the power negative 3. The charge is 1.26 times 10 to the power negative 8. Number of electrons lost is 7.869 times 10 to the power 10. And the electric force is the same as the gravitational force. The errors are unequal distribution of charge on each piece of tape and loss of charge when handling the tapes. The assumptions that I can make are: assume that air resistance is negligible, assume that charge is distributed evenly on each piece of tape, and assume that the long tape is a point charge. For the first question, if the electron and proton swapped charges, the observation and results would be the same. The charged pieces of tape would be negative and still repel each other and attract the positively charged pen. For the second question, it is important to handle the charged tapes as little as possible, as the charged tapes would become neutral as they try to gain back the lost electrons when they come on contact with the hands or other objects. Thank you.